let's look at question number 20. The question says the stone Q is thrown with velocity u at an angle of 75 degrees to the horizontal. Another stone R is thrown with the same velocity u but at an angle of 15 degrees to the horizontal. The ranges covered by the stones will be, we are still on range. The general formula for range is u squared sine 2 theta over g. We are dealing with two bodies, stone Q and stone R. The question says we are to, what will be the ranges covered by these two stones? Let's take it one by one. For stone Q, what will be the range? For stone R, what will be the range? Okay? The range for Q will be equal to u squared sine 2. What is the angle of projection for stone Q? 75. 2 times 75 sine 2 theta, which is 2 times 75 divided by g. Then, which is equal to u squared sine 2 times 75 will give us 150. 150, that is for Q, divided by G. Then let's quickly go to the range for the other stone. We are dealing with stone Q, and at the same time we are dealing with stone R. So small r, the ranges for the stone R will be equal to u squared sine 2 theta. But the angle of projection for R is not 75. We are given the angle which is 15. This is times 15 divided by G. U squared sine 30 divided by G. Okay? For the range for this, the range for the stone Q is this. The range for the stone R is this. Okay? So how are we going to get the range for each of them? Okay? In this case, we are not given the velocity, and our G is also the same. So what we are going to do in this case is this. For our stone, the ranges for Q will now be equal to sine 150, so it can be written as u squared. For sine 150, it can be written as 180 minus 150 divided by G, which is equal to u squared sine 30 divided by G. You are going to notice something from here, that for stone R, u squared sine 30 divided by G. For Q, u squared sine 30 divided by G. And the question says, what will be the range of the two stones? From the option we are having here, option A, the option A says the ranges covered by the stone will be greater than Q. For option B, the ranges covered by the stone will be greater than R. Option C, the ranges covered by the stone will be the same for Q and R, and that is the best option. The ranges covered by the stone will be the same for both Q and R. If you look at this very well, they are the same. The ranges covered by the stone will be the same for both Q and R, and that's the best option, the answer to the question. Question number 21. When taking a penalty kick, a footballer applies a force of 30 Newton for a period of 0.05 seconds. If the mass of the ball is 0.075 kg, calculate the speed with which the ball moves up. This question is about the momentum, Newton's laws of motion. In this question, we are given the force F to be equal to 50 Newton, we are given time t to be equal to 0.05 seconds. Then we are given another value, which is the mass of the ball, 0.075 kilogram. From, you remember this formula? V minus U over T. But before the ball is being kicked off, velocity is equal to 0 because it will be at rest initially. So F will be equal to mv over T. So in this case, we have to calculate the speed with which the ball moves up. To calculate the speed, Ft, so that V will be equal to Ft over m. So in this case, we are given the force, which is 10, the time, which is 0.05, then divided by the mass, 0.005. In this case, we have 10 times, this is 5 times 10 raised to power minus 2. Then this one is 75 times 10 raised to power minus 3, which is equal to 5 here, 1, 5 is 75. We are still going to have 10 raised to power minus 2, then plus 3, all divided by. So once 5 have gone in 75, we are going to have 35. Okay? Then 10. This is 10 raised to power 1. And 10 raised to power 1. Okay? 10 times 10. 10 raised to power 1 is 10. Which is equal to 100 over 35. And 100 over 35 will give us 2.85 liters per second. And that is the answers to question number 21. Question number 22. A jet engine develops a thrust of 270 Newton seconds when the velocity of the exhaust gases relative to the engine is 30 meters per second. What is the mass of the material ejected per second? What is the mass of the material ejected per second? So we are still coming back to Newton's laws of motion. F is equal to mv over T. We are given 270 Newton seconds. And if you look at the word Newton seconds, for Newton is force, for seconds is time. We are having Ft is equal to mv. That is, impulse is equal to momentum. This is impulse, this is momentum. So by the time the unit says Newton seconds, that is, we are combining both force and time together. So instead of giving us ordinary force, we are given both force and time together. So in this case, we are going to have 270 under Ft for 270 Newton seconds. Then we are also given the value for velocity, though we are looking for mass now. It's going to be 270 over 30. 0 can do 0. So that if you divide 3 by 27, we are having 9 kilograms. 9 kilograms. And that's the answer to question number 22. Question number 23 said a rocket burns fuel at the rate of 10 kilograms per second and eject it with a velocity of 5 times 10 raised to power 3 meters per second. The thrust exerted by the gas on the rocket is, so how do we calculate it? The thrust here is equivalent to the force. So from Newton's law over T, or if you look at the parameter given to you, they said 10 kilograms per second. If you are to interpret this one now, you are talking about mass over time, kilogram per second, mass over time. That is, they have combined both m and t together for you. Kilogram and seconds, mass over time. So the thrust, which is force, will now be equal to, for m and t has been given as 10. then times velocity, which is 5 times 10 raised to power 3. And if you are to calculate this one, this is 10 times 5, 50 times 10 raised to power 3. If you try to shift this one to the back, 5 times 10 times 10 raised to power 3, which is 5 times 10 raised to power 4 meter. For the thrust is in Newton. And that's the answer to question number 23. Question number 24 says a 0.05 kilogram bullet traveling at 500 meters per second strike a thick vertical wall. It stopped after penetrating through the wall a horizontal distance of 0.25 meters. What is the magnitude of the force for the wall exerted on the bullets? The magnitude of the force will be equal to the mass of the body and the acceleration. We are given the mass. We need acceleration. To get the acceleration, we are coming from the equation v squared